Hello everyone, welcome to the channel. Today I'm going to walk you through an exciting AI-based project I built, a pulmonary fibrosis prediction system. This intelligent tool forecasts lung capacity and classify fibrosis severity using both patient's data and machine learning. What is pulmonary fibrosis? Pulmonary fibrosis is a serious lung disease where tissues become scarred over time, making it hard to breathe. Accurately predicting its severity and progression can be life-saving. That's where this product comes in, providing a smart way to assist doctors with early intervention. What the app does. Let me show you how the app works. First, we enter the 5 FVC value, that's forced vital capacity, a measure of lung functions. Then we input 5, then the baseline FVC, which helps in determining how far the patient has declined normal. After clicking the prediction, the app uses a trained ML model to forecast two future FVC values and automatically classify the severity. In this case, the result is mild fibrosis. How it works? The model uses the recent FVC values to forecast lung capacity and estimate disease severity. It trains on the 20 GB dataset combining historical FVC data, which is tabular data and numerical, and also the CT images, which are visually. The machine learning models trained on Kaggle datasets that combines time series forecast and classification techniques for FVC prediction. I use models like XGBoost and for severity classification, a threshold-based classifier labeled as mild, moderate, and severe. You can think of this as a hybrid model. One part predicts future lung capacity while the other uses those predictions to estimate disease severity. This in, let me show let me show you the coding part. Loading the dataset in this one, you can see this is the problem statement. Everything we got from the Kaggle. This is the data processing. How we are first importing all the necessary after loading the dataset, EDA, which we called exploratory data analysis, then visualizing diagram and model training. That's first importing the libraries. We are using the NumPy, Pandas, Matplotlib, Seaborn, and TensorFlow. Then set integer values. Load the data. Dataset details are train, SVC, test, train, label. This is the data, numerical data for the table data set, tabular data. The column details in the FVC and test FVCs, patients, week, FVC, percent, sex, age, and smoking status, and ADA. Concise summary. This is train sets and descriptive statistics. Missing values. Patient count. Unique patient. Frequency of the patient in the train set. Frequency and the patient. Number of CT scan for each patient in the train is 30, 31, 49. CT scan numbers in the CT scan. Number of CT scans for each patient in the test. Descriptors of the distribution of the week, frequency and the weeks. You can see distribution of the patient age. You can see distribution of the patient gender. Males are 139, females are 70, 37. This is a male and female. Blue are male, Even this one, distribution of age and gender, dist- gender-wise smoking distribution, records with patient have never closed, FVC distribution, FVC versus smoke status, FVC versus age. Males have higher FVC than the female, irrespective of the ages. FVC versus week. Most of the FVC test is done in between 20 to 0 weeks. Also, the ex-smokers males have more FVC than others. FVC of the oldest and younger person. Percent distribution. Percent versus smoking status. Percent of oldest and youngest person. Percent versus age. Percent versus FVC. Patient overlap correlation among the features are visualizing diagram images. This is a CT scan we got. Around the CT scan, we have 10,000 plus images we got from the Kaggle dataset. In this one, we have 20 images which are serial wise. This is the negative view of the image which you saw in the above earlier. These are threshold value and frequency. Visualizing using the GIF. This is if we combine all the images. Tissue segmentation, we have this. Using which we can see how the lungs are healthy or unhealthy. This is the process how we can see that lungs are healthy or damaged. This is model building we are using. First layer input, second is efficient net backbone, third is global average polling. We will do additional input layer. We will use noise augmentation, concatenation. We will use dropout regulation and output layer. These are the we are using assigning the values for this. These are the percents we got using this. Then we are shaping the data. This is the CNN model. These are the values are mean absolute error, which EA, MEA, uncertainty in prediction. After that, we got this much. These are the FVC and confidence value. Let's recap the main features. The five we uses the five historical FVC value for prediction, machine learning severities using tabular user friendly interface to model for medical practices and researches. This system could eventually integrate CT scan analysis to enhancing accuracy with image-based learning. Thank you for watching. If you are interested in AI for healthcare or want to explore the code, check out the GitHub link in the description. Don't forget to like, share, and subscribe for more AI product checks and tutorials. See you next time. Thank you.